You are welcome back to Idowu Math class. Let's consider another concept under whole number, which is factors. When we say factors, what do we mean? Factors of a number are other numbers that can divide the number without any remainder. Factors are best explained by example. Take for instance, factors of 12 are all the numbers that can divide the 12 without remainder, like 1, 2, 3, 4, 6, and 12. Always, factors of a number includes the number itself. That is why factors of 12 include 12 also. Factors of 20 are 1, 2, 4, 5, 10, then 20. If you look at it very well, you observe that 1 is a universal factor. 1 will be the factor of any number you talk of. Another one, let's consider factors of 15 will be 1, 3, 5, and the 15. And lastly on it, let's consider factors of 45. Factors of 45 will be 1, 3, 5, 9, 15, and 45. Those are the factors of 45. 1 can divide into 45. 3 can divide the 45. 5 can divide 45. 9 also can divide 45. And 15 can divide 45, while also 45 can divide 45. So that is that about factor. Let's consider the next concept under whole numbers, which is prime numbers. What are prime numbers? Prime numbers are whole numbers that have only 2 factors. The first prime number is 2, followed by 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, and so forth. Why don't we include 1 into prime numbers? 1 is not a prime number because it has only one factor. The factor of 1 is 1, and it's only 1. And prime numbers must have 2 factors, no more, no less. If it is more than 2 factors, it's not qualified to be a prime number. If it is less than 2 factors, it's not qualified to be a prime number. Also, 9 is not qualified to be a prime number. Why? 9 has 1 as a factor, 3 as a factor, 9 also as a factor. So that's 3 factors altogether. So 9 is not a prime number. Also 15 is not a prime number. Why? 15 has 1 as a factor, 3 as a factor, 5 as a factor, 15 as a factor. 4 factors altogether. So a prime number must maintain only 2 factors. So we can see why 15 is not a prime number. Also, 21 is not a prime number because it has 1 as a factor, 3 as a factor, 7 as a factor, 21 as a factor. It's more than 2 factors. Also, 27 and other numbers like that. 27 also has 1, 3, 9, and 27 as factors. So any number that have more or less than 2 factors is not a prime number. So I want to believe you understand why 1, 9, 15, 21, 27 and others like that are not prime, and why 2 is a prime number. 2 has 2 factors, as you can see. It has 1 and 2 that can divide into it. 3 also has 1 and 3. All of them, 5 has 1 and 5, 7, 1 and 7, 11, 1 and 11, and so forth. And that is why they are prime numbers. You can now be sure of prime numbers anytime you want to extract prime numbers from a set of large numbers. So that is it. Another concept is odd numbers. Odd numbers are whole numbers that are not exactly divisible by 2. The first odd number is 1, followed by 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and so forth. These are sets of odd number. It's an infinite set of number. That is, it is endless. So, something is noticeable here. The difference between any 2 consecutive odd number is 2. Don't forget, the difference between any 2 consecutive natural or whole number is 1. Don't forget, we have done that. But now, here we are in odd numbers. The difference between any 2 consecutive odd numbers is 2. As you can see, the difference between 1 and 3 is 2. Between 3 and 5 is 2. Between 5 and 7 is 2. The difference between 7 and 9 is 2. Any two consecutive 2 numbers that follow each other closely are consecutive. So, algebraically, if y represents a number which is odd, the next number to it will be y plus 2, because of the established fact that the difference between any 2 consecutive odd number is 2. The next one will be y plus 4, y plus 6, y plus 8, and so forth. That is algebraically. Let's consider some examples that will really show the application of what I'm talking about. Let's look at this example 1. The sum of 3 consecutive odd numbers is 57. Find the numbers. Let the numbers, permit me to use NO to represent the numbers, NOS. Let the numbers be y plus 2, y plus 4. For 3 of them, 1, 2, 3. If you need more, if there are 4, you create more. So their sum then is said to be 57. That's sum given. But the sum by calculation is y plus 2 plus y plus 4. This is sum by calculation, which must be equal to sum given. To the sum given. So y plus y gives us 3y plus 2 plus 4, that's 6, equals 57. This is a simple linear equation that must be solved. Collect the like terms. We have 3y equals 57 minus 6. 3y equals 51. Divide both sides by 3. So we have 3y divided by 3 equals 51 divided by 3. So y is equal to 17. How? 3 in 5 is 1. It remains 2. Use the 2 with the 1 forming 21. 3 in 21 is 7. Therefore, the numbers are y plus 2, y plus 4. Whereas y is gotten to be 17, 17 plus 2, 17 plus 4. Finally, 17, 19, 21. So these are the numbers. You can see that they are odd numbers and they are consecutive. 17, 19, 21. Example 2. The median of 5 consecutive odd numbers is 17. Find the numbers. Let the numbers be x, x plus 2, x plus 4, x plus 6, 1, 2, 3, 4. It remains 1, x plus 8. They are already arranged in ascending order. 1, 2, 3, 4, 5. If the number of items in the data is 5 or any odd value, definitely the median of such set of data or set of numbers will be a single number in the middle. Therefore, the median here also will be this x plus 4 in the middle. And median has been given to be 17. That means the median by calculation here is x plus 4, which must be equal to the median given, which is 17. So this simple linear equation must be solved to have x equals 17 minus 4. X equals 13. So if x equals to 13, and the question is that we are to find the numbers. So therefore, the numbers, the first is x, followed by x plus 2, then x plus 4, x plus 6, x plus 8. That is 13. I will add it straight away. 13 plus 2, 15. 13 plus 4, 17. 13 plus 6, 19. 13 plus 8, 21. These are the numbers. 1, 2, 3, 4, 5. These are the 5 consecutive odd numbers. Example 3. The median of 4 consecutive odd numbers is 24. Find the numbers. Don't forget, you are calculating the median of 4 numbers like 2, 3, 4, 5. These are 4 numbers. Because the number of the items in the set of number is even. Like it is 4 now. If it is 6, 8, 10, 12, any even number, then 2 numbers will fall into the middle. Not a single number will be in the middle. 2 numbers will fall into the middle, and the 2 numbers will be added together and divided by 2 to give the median. So also in this case, let's say let y, y plus 2, y plus 4. How many are there? 4. Y plus 6 be the numbers. Therefore, the median will be 1, 1. 2 numbers fall into the middle. These 2 numbers will be added together for median. Median will be y plus 2 plus y plus 4. These 2 numbers in the middle, they are added together and divided by 2 to give the median. And it is equated to 24 that has been given to us before. So we have y plus y, that's 2y, plus 6 divided by 2 equals 24. At this juncture, you cross multiply. When you cross multiply, 1 times 2y plus 6, that is 1 into 2y plus 6 equals 2 times 24, that is 48. If you use this 1 to open this bracket, it is still 2y plus 6, which is equal to 48. We collect the like terms. Collecting the like terms, we have 2y equals 48 minus 6. So it is 2y equals 42. In short, 2y divided by 2 will be equal to 42 divided by 2. So y is equal to 21. If y is equal to 21, find the numbers. The numbers are y plus 2, y plus 4, and finally y plus 6. How many are they? They are 4. 1, 2, 3, 4. That is, y is 21. 21 plus 2, that is 23. 21 plus 4, that is 25. 21 plus 6, that is 27. These are the 4 consecutive odd numbers. That is the end of that. The next concept is multiples. When we say multiple, what do we mean? Multiples are best explained by example, like multiples of 2 are all the numbers that 2 can divide are multiples of 2, starting from 2 itself, 2, 4, 6, 8, 10, 12, 14, and so forth. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, and so forth. Multiples of 7, they are 7, 14, 21, 28, 35, 42, 49, and so forth. Multiples of 11, I jump some numbers. We cannot list all of them, just for you to have idea to list, but few. 11, 22, 33, 44, 55, and so forth. Those are the multiples of 11. And so forth like that. That is the idea behind the concept multiples of numbers. Let's consider the following examples on multiples. Example 1. Which of these is not a multiple of 13? That is to say, 3 out of 4 options here are multiples of 13, but a particular one there is not a multiple of 13. That's the interpretation of the question. So, which one is not a multiple of 13? If you want to cite or deduce the multiples of 13 among the options here, what do? Multiples of 13. 13 times 1, is it there? No. 13 times 2, is it there? Yes. 26. 13 times 3, is it there? Yes. 39. 13 times 4, something like that is not there. If you look at it, 169 is 13 times 13, which is 169. But 113 is not a multiple of 13. If you continue to multiply 13 by numbers, 13 times 1, 13 times 2, times 3, times 4, you can never get 113. So 113 is not a multiple of 13. So the correct option here is option D, which is not a multiple of 13. Example 2. The following are not multiples of 15 except, what's the interpretation of this question? The meaning is, out of these 4 options, 3 are not multiples of 15, but there is a particular one that is a multiple of 15. That is the interpretation of the question. The following are not multiples of 15 except, that is except a particular one. So which one is the particular one that is a multiple of 15? The rest of them are not multiples of 15. Which one is a multiple of 15? 115 is not a multiple of 15. 215 is not a multiple of 15. 155 is not a multiple of 15. But 225 is a multiple of 15, and that is the answer. Option B is the correct answer. So that is where we are going to stop under multiples for now.